Hey, it's Mr. Estrada here, and our learning target is I can apply the polygon angle sum theorem to find missing angles of a polygon. So a polygon is a closed plane figure with at least three sides. So some examples of polygons are triangles, quadrilaterals, pentagons, hexagons, octagons, and so on and so forth. Any figure with at least three sides is a polygon. And just so you know, for reference, the prefix poly means many. So these are all examples of polygons here. Okay, so the polygon angle sum theorem says that the sum of the interior angles of any polygon is n minus 2. N simply stands for the number of sides. So we could say that the sum of the interior angles of a polygon is equal to n minus 2 multiplied by 180. So let's look at an example. It says here, what is the sum of the interior angles of the regular heptagon below? So regular, when you see that word regular and it's referring to polygons, regular means that all of the interior angles are equal. So all of the interior angles here are equal to each other. And heptagon means 7 sides. So it says, what is the sum of the interior angles? Well, we know that the formula says the sum of the interior angles is equal to n minus 2 multiplied by 180. That's what the formula says. So let's use our formula. N stands for the number of sides, so there are 7 sides. So 7 minus 2 multiplied by 180. 7 minus 2 is equal to 5. And 5 multiplied by 180 is 900. So what we know is that all the angles inside this heptagon add up to 900. They must add up to 900. The next question says, what is the measure of one interior angle rounded to the nearest tenth? Well, if we know that the sum is equal to 900, and we want to know what one of them is equal to, and we know they're all equal, we can just say 900 divided by 7, and that will give us what? What's 900 divided by 7? Rounded to the nearest tenth, it's going to give us 128.6. So the measure of one of the angles is approximately 128.6. The measure of the interior angles, that is. And it's important to note that. And of course, all these add up to 900. Next question says, what's the measure of one exterior angle? So when it says exterior angle, it's talking about outside. So it's necessary for us to draw lines to get exterior angles here in our figure, just so we could visualize how we could find the exterior angle. You'll notice that the exterior angle and the interior angle are supplementary. So if we want the measure of one exterior angle, we can just say 180 minus 128.6, and doing that will give us the value of the exterior angle. So 180 minus 128.6 is approximately 51.4, or it is 51.4. So that's the measure of one exterior angle. Okay, we looked at that already. For a regular hexagon, find the following. The sum of the interior angles, the measure of an interior angle, the measure of an exterior angle. So you'll probably realize by now that you really don't need a picture to solve these types of questions, because you know the formula says the sum of the interior angles is equal to n minus 2 multiplied by 180. A hexagon has 6 sides, so we get 6 minus 2 times 180. That's 4 times 180. And we multiply 4 by 180, and we get 720. So the sum of the interior angles is 720. And that says sum of interior angles, and I'm using a symbol there for angles. Let's do part B. Part B wants the measure of n interior angle, or just one of them rather, so we have to take the sum and divide it by the amount of sides. So the sum of the interior angles, let me just write the formula, divided by the amount of sides, or by n, and that will give us 720 divided by 6, and 720 divided by 6 is 120 degrees. Letter C, from before, from example 1, you know that the exterior angle is supplementary to interior angle. So to get the exterior, what we do is 180 minus 120, and we get 60 degrees. So that's the answer to letter C. So 120 is the measure of one interior, and 60 is the measure of an exterior. Okay, so based on the work we just did, we could say an interior angle is equal to the sum of the interior angles divided by n, right? That's how we got the measure of one interior angle here. And we could say that an exterior angle is equal to 180 minus the interior angle. So that's what we could say so far. Example 3. So here we have an irregular polygon. And the reason why it's irregular is because the angles are not equal. So here we are asked to find the measure of angle y and then the measure of angle x. All right, so let's begin. This is a pentagon. Pentagon has 5 sides. So we know that the sum of the interior angles is equal to n minus 2 times 180. So we know that. And why don't we just go ahead and find that now? So that's going to be 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is equal to 540. So 3 times 180, that's equal to 540. So we know that all the angles inside, they must add up to 540. But we don't have all the interior angles. What they gave us were the exterior angles. But we could use those exterior angles to find the interior ones. So we know, for example, that this angle here has to be 120. Because 120 plus 60 will give you 180, right? These two angles here have to add up to 180. So that's 120. And this angle here, the interior one, is going to be 180 minus 84, which is 96. So this angle here is 96. It's hard for you to see that, right? 96. And this angle here is going to be 180 minus 68, and that's 112. So if we want to solve for y, we know that y plus the rest of the interior angles, which are 140, 112, 96, and 1, 2, 3, 4. I'm missing one more. I got the 140, I got the 112, I got the 96, the 120. We know that all these interior angles, they have to add up to 540. So when you solve for y, you get y equals 72. So y is equal to 72. Well, once you know that, it's easy to find x. X is supplementary to 72, so we know that x plus 72 have to add up to 180, and 180 minus 72 is equal to 108. So that's the value of x. X is 108, y is 72. Okay, I want you to do a quick investigation with regards to exterior angles. What was the sum of the exterior angles for example 1? So here's example 1. We know that the measure of one exterior angle is 51.4. So if you want the sum, you can just add them all up, all the 51.4s, or you can just say 51.4 multiplied by 6. So let's take it back here. And if you do that, it will give you approximately 360. Now, the reason why it doesn't give you exactly 360 is because you round it. So if you add the exterior angles, for example 1, you get 360. Go back and add the exterior angles for example 2. You should also get 360. Go back and add the exterior angles for example 3. You'll also get 360. Examine your answers above. Do you see a pattern? Yes, there is one. The sum of the exterior angles of a polygon is 360. So that's also something else to keep in mind, all right? You don't want to confuse exterior angles with interior ones, all right? So remember, this is talking about exterior angles. Okay, that's all for now. I hope this video helps. Do try some of the practice problems. Get some practice in before class. Have a good one. Take care.